In this section, we're going to look at several different types of equations and talk about how to solve each one. We're going to begin with what is called a linear equation. So what is a linear equation? A linear equation is an equation where the highest power of x is 1. It's an equation where if we graph the equation, we get a line. It has the form ax plus b is equal to 0, where a and b are numbers. For example, 3x plus 5 is equal to 0. So let's begin with this example. Solve the equation 3 times the quantity x minus 2 is equal to 5 times the quantity x minus 1. Note that it's a linear equation because when I look at the equation, I don't see any exponents. There are no powers of 2 or 3 or 4, and the assumption is made that if there are no exponents, that the highest power of x is 1. So my job becomes to simplify this equation and solve it for x. So I'm going to begin with the distributive property. So we can take this 3 and we can multiply it through that set of parentheses. So 3 times x is 3x. 3 times negative 2 is negative 6. We're going to do the same thing on the right-hand side. Using the distributive property, we're going to distribute the 5 through the parenthesis. So 5 times x is 5x. 5 times negative 1 is negative 5. Now, the next thing that we need to do is we need to try to get the x's on one side and the numbers on the other. And so we're going to start moving terms around. It doesn't really matter what you move. I'm going to work on this minus 6 right here. Remember that you're going to do the opposite. So if this is a minus 6, then I'm going to add 6, and I need to do it to both sides. Okay, so now we simplify. This minus 6 and this positive 6 cancel out. Leaves me just the 3x on the left. On the right-hand side, I still have the 5x. And negative 5 plus 6 is plus 1. And again, use your calculator at any point you need to add or subtract these numbers. Okay, keeping in mind my goal is to get the x's on one side and the numbers on the other, I'm going to now subtract the 5x from both sides. Causing it to cancel here. So on the right-hand side, I'm going to be left with 1. And on the left-hand side, 3x minus 5x is going to give me negative 2x. Again, your goal is to get x by itself. So the last thing that I need to do is I need to divide because the negative 2 is multiplied by the x. So I'm going to undo it with division. Divide both sides by negative 2. That's going to cause these negative 2's to cancel, and it's going to leave me x is equal to negative 1/2 for my solution. Okay, let's look at another one. Again, when I look at this problem, I don't see any exponents. So that tells me that this is a linear equation. So we have in parentheses 2x plus 1 times the quantity x minus 1 is equal to, in parentheses, x plus 5 times the quantity 2x minus 5. So again, we're going to begin with the distributive property, but it's a little more complicated here because of the terms that we're multiplying together. So at this point, we're going to really quickly review the FOIL method. Remember that the FOIL method gives you a procedure to distribute when you have parentheses like 2x plus 1 times x minus 1. So recall that the F in FOIL stands for the first terms. So I'm going to multiply the 2x times the x. and that's going to give me 2x squared. The O stands for the outside terms. So that's going to be the 2x and the negative 1. So 2x times negative 1 is going to be minus 2x. The I stands for the inside terms. So we're going to be multiplying the positive 1 times the positive x. That gives me a positive 1x. And the L stands for the last terms. So we'll multiply the positive 1 times the negative 1. Now we're going to do the same thing on the other side. So F standing for first, we're going to multiply the x times the 2x. So that makes 2x squared. The O for the outside, we're going to multiply the x times the negative 5, making negative 5x. The I for the inside, 5 times 2x makes 10x. And the last, 5 times negative 5 makes negative 25. Now we'll look and see if any terms can be combined. So what I notice is that this negative 2x and the positive 1x can be combined on the left, and the negative 5x and the positive 10x can be combined on the right. So let's rewrite making that adjustment. So I still have the 2x squared. When I combine my middle terms, that's going to give me a minus 1x, and then I still have the minus 1. On the right-hand side, 2x squared. Combining your middle terms gives you a positive 5x, and then minus 25. So now that we've combined like terms, we're ready to start moving things around. Remember, your goal is to have the x on one side and the numbers on the other. So I'm going to start by subtracting a 2x squared from both sides. Now, when I do that, notice that the 2x squareds cancel on the left, but they also cancel on the right. So that helps me simplify this pretty greatly. All right, so I'm going to have left a negative 1x minus 1 is equal to a 5x minus 25. Okay, and again, there's no right thing to do next. You just want to move either an x term or a number. I'm going to go ahead and move this minus 1, so I'll do the opposite by adding 1. All right, that's going to cause it to cancel on the left. All right, so I'm going to come up here to the top and finish this thing up. So I have a negative 1x is equal to 5x minus 24. All right, the next thing I'm going to do, remembering that I want x's on one side and numbers on the other, I'm going to subtract this 5x from both sides. So negative 1x minus 5x is negative 6x. The 5x minus 5x cancels, and we're left with negative 24. The last step, we have a negative 6 connected to the x with multiplication. We'll undo that with division, so we're going to divide both sides by negative 6. And so our final answer becomes x is equal to negative 24 over negative 6, which is going to equal 4. And these linear equations are very easy to check. If you want to check to be sure that you have the correct answer, you simply plug the 4 into the original equation for x and make sure that you have a true statement on both sides. All right, one other example that we're going to look at is an example where we have fractions. So we have the problem 9x over 4 plus 5 halves is equal to negative 1 half. For most of us, we would prefer not to work with the fractions. And so in order to get rid of the fractions, we're going to multiply each term in the equation by a number. And so we have to figure out what number we're going to multiply by. So I'm going to look at my denominators. One denominator is a 4. And so what I'm going to do is come up here and I'm going to write some multiples of 4. So 4 and then 8, 12, 16, and so forth. Another denominator that I have is 2. So I'm going to do the same thing with the 2. I'm going to come up to the top and I'm going to write some multiples of 2. So 2, 4, 6, 8, 10, and so forth. What we want to multiply this expression by is the smallest thing that is occurring in both lists. So if you look at your list, 4 is the smallest value in both lists. And so I'm going to come to my problem and I'm going to multiply each term in the problem by 4. So this term is going to get multiplied by 4. This term is going to get multiplied by 4. And finally, this term is going to get multiplied by 4. We have to multiply each term in order to keep the equation equal. All right, so if you look at what happens on the first term, the 4's will cancel out. You have a 4 in the top and you have a 4 in the bottom, and so those are going to cancel out and leave you just the 9x. Okay, let's look at what happens on the 4 times the 5 halves. This 4 is technically over a 1, and remember that when you multiply fractions, you multiply the top and the bottoms. So we're going to multiply 4 times 5, that's going to be 20, and then 2 times 1, which is going to be 2, and we know that 20 divided by 2 is 10, so I'm going to go ahead and put the 10 in there. Okay, now we're going to do the same thing on this last one. So remembering that the 4 is over 1, we're going to multiply top times top. So that's going to be negative 1 times 4 is going to be negative 4. 2 times 1 on the bottom is going to be 2. And again, let's simplify. So 4 over 2, we know that that's equal to 2. Now this equation is much easier to solve than the form that we started with the fractions. So what do we want to do? We want to get the x's by themselves and the numbers on the other side. So this plus 10, let's undo it with a minus 10. So that's going to give me 9x is equal to negative 12. To solve for x, we have 9 multiplied by the x, so we're going to undo it with division. So we'll divide both sides by 9, which gives me x is equal to negative 12 over 9, which is a fraction that we can reduce. So both 12 and 9 are divisible by 3. So when we do that, 12 divided by 3 is going to be 4, and 9 divided by 3 is going to be 3. So our final answer, x is equal to negative 4/3.